if somebody can try, just give me a quick question here, then I can confirm whether I can hear you. I can hear a child somewhere in the background, so that's good news.
Hi Willie, kan jy my hoor? Karen hier.
Kan, dankie Karen.
Okay.
All right, questions please.
Willie, can I say something? I don't know how we're going to say how we organize this. Maybe with the chat, and you decide who should speak. I see there's something in the chat where someone asked if Otello can connect to other devices. Maybe I can just say that in general that is true. We can connect to other devices. At the moment we support the CT Lab range of devices, plus devices who can export data in a PQDIF format. But the CT Lab devices very different in their implementation. For example, a vector graph, an impedograph, and a vector 3 have nothing in common, and we support all of them. So we can connect to other devices given that there was a business case. The impedograph, for example, wasn't supported, and we had a business case where a client said, well, we have 60 of these things, and if you implement this, we will sign up, and we went ahead and implemented the support for that.
Thank you, Jacobus. I think if I can put a question back that I know that people's going to ask as well, is if you talk on the device side, how locked in are you with the device? Now, we participated in quite a few international tenders. One in Israel is dominant, and another one in Italy for the Enel tender was dominant. And then also the South African one. And all of them called for complete autonomous operation. So on the Vector 3 device, for instance, we've got a web interface now lately. So you can configure that device completely on its own using either a mobile phone, tablet, or PC on its own. So you don't even need any configuration software. But at the same time, we support FTP kind of configuration where you can send the device a configuration file and the device will respond back with responses on how you configured it. And the same goes for data retrieval. So you can send a command via file to the device, and the device will make a database query, will put the result in a file for you, and you can retrieve that file from the device itself. So the device is completely autonomous. It can operate completely autonomous as part of another system. We also implemented on the higher level REST commands and so on that allow you to directly control the device with the REST server on that side, but that's a little bit complicated even for me. This is Jacobus' territory. On the other side, the Osprey Pro, as Jacobus rightfully said, we have standard interfaces to talk to various devices with total different nature already. And just a statement from CT Lab's side, Osprey Pro is intended to be a standalone platform that can be used with various other devices. So currently, an Excel spreadsheet, PQDIF, Comtrade file imports are already supported. And technically, if you can ask my own sentiment, I would not like to directly communicate with any third parties' devices in the field. I rather want to talk to their databases. Simply because between third-party software and their devices, a lot of value adding normally takes place. And so if you directly talk to the device, a lot of added value gets lost. So it will be much better to interface to third-party data systems than to talk to third-party devices. I hope that also answers some questions.
I believe it's Hans here all the way from Tanzania. I just want to ask you, touch on it, about what we currently see here happening in the industries that I'm involved or have or planning to put meters. So DIPS is we have quite a lot of dips, and it, as you know, it impacts a lot on the process of the plant. So one of the clients asked me, so normally what happens is that when you have a dip or a power interruption where your instrument is hooked into the utility side, and then the industry switch over to the standby generators. So you don't know in terms of billing, and it seems that becomes a bit of an issue, especially here, that they want to see what's the total cost of energy, including of the diesel generator or even renewable generator. I don't know the deal if it has the functionality, but it's perhaps something to look into the to include in your product in the future. The second thing that I've picked up, especially it's coming now in this country, is where a lot of industries are implementing rooftop solar, and this to reduce the bill. But I also see a benefit in terms of low voltage right-through capabilities, injecting reactive power to at least reduce the depth of the dip. So I just would like to know, especially this will become in future a criteria where clients will require from these solar companies that it must be measurable, how you can measure the impact of the solar or the inverter into power dips. I don't know if you can include that. Then one can clearly see that what is coming out of the inverter system in terms of a dip, and then also what is the impact going into the utility grid. That's all from my side.
Thank you, Hans. You've asked a mouthful, and I'm going to give you a short answer that I think that's going to help everybody in terms of it. Keep in mind that the big data database is a platform. So just as an example, we implemented a sort of a demand management system for a mine up in Tanzania, where the system the system doesn't have enough capacity for them. So whenever the demand reaches a certain level, we automatically start the diesel engine for them and keep it running until the demand drops on the other side. So controllability is definitely available. The system even have a SCADA kind of viewer where you can live keep in a control room, have a SCADA kind of view available there. And then control functionality, for instance, like the virtual power station, can be implemented, because you can implement business rules where the device will automatically retrieve in the night before all the set of rules for it to operate with, and during the next day to continue and playing out those rules and so on. So having a platform, it is really and having access to database, filing system, Ethernet communication, and different protocols, it's very easy to implement control schemes on top of it. And I've seen somebody here on the questions also asking, can we grow the product to participate in demand management programs larger and so on? Yes. CT Lab in the past spent a lot of time on the measurement side and so on, but the platform is now at the point where we can start controlling. We already proved the principle in Tanzania, and we're very keen to get involved in some of the control schemes that's available.
It's Francois here. I'd like to add to that question. I think that's a very interesting topic that you are looking at there. In terms of this experience that you're talking about in Tanzania, in terms of integration of your large data system and controllability with existing hybrid plant controllers or power plant controllers, I mean, do you foresee that as being a challenge, or how would you propose targeting that? Because obviously that's a key component, is to integrate with the existing control system.
Francois, with most of the control systems, in part of the control route, you need a sensor, and you need to get the information to the controller. So if there's already a controller sitting making decisions and all the infrastructure is already there, then the logic place will be to feed in information for the controller. And that kind of information can be high-level information. It need not be raw volts and amps kind of information. For instance, we can derive new data like, for instance, network impedances, or a combined bill, or you know, something academic. And then you can feed that in real time into the system. There are so many possibilities here. I think we can start there. But on the control side, exactly the same. We've developed the front end, we call it the meter gateway. Now that's the place where you directly communicate or interface to the device. Now within the meter gateway, we can implement any additional intelligence. So at that point, you can interrogate the database, you can interrogate other devices from it, and 1 + 1 might just give you 3.
Thanks, Willie.
I just want to say another one. On top of the device, on each one of the devices, we have a virtual a development environment. It's called Lua. It's a Lua environment. It's something similar to Visual Basic. But one of the PhD students at Potch University implemented a complete rotation, slipping pole rotation or slipping pole protection relay within that space. So that virtual machine on board of the device itself, keep in mind it's an edge computing device. So on the device, we can add a lot of intelligence there. And that environment has got access to raw waveforms, Ethernet, the filing system, the relays, the digital inputs, all of that is accessible. To the people that ask questions on the chat, Jacobus and the rest of the team is responding to that. So if you forgive me, I can't keep pace. I think there's a lot of things happening there, so my apologies. One of the latest contributions that we are making right now on the Otello system is the implementation of Goose and streamed values. And I think that will add a lot of benefit to the substation automation world.
Willie, there was a question on what are we intending to do with maximum demand control?
Okay. The answer back is, you please tell me. Because at the end, the focus was right now on the measurement and making things available. And right now, I do not have a single customer that are interested in or that has approached us with a requirement on that regard. The technology is easily to be adapted on that side, but I have no specification right now on how to do that. Just also comment on this side, Johan Pieters joined us recently, and Johan Pieters is he's the sales representative and so on, but he's also certified energy manager, certified energy engineer. And so that part of the business, the whole demand management and reporting and that side of the business will definitely grow very soon. And I see something that I saw from SEP side. We support the IEEE and EN standards of it. So report generation is a strong point of ours. So if you have a need or a specific market need for a specific kind of report, all the tools are in place to generate it according to different standards. Me and Jacobus lately talked about reporting more reporting more towards industry. So to use the Sabima curves and the sensitivity analysis, those kind of things, that is, you know, for industry, the NRS 048 is of importance from a legal point of view, but many customers are more interested in whether their equipment can ride through or not.
Sorry, Willie, if I can come in here. I think you've touched on it in terms of the energy side of the business. So the discussion becomes more of also an energy discussion in terms of the tsunami of changes that you've referred to in the beginning of the presentation. So traditionally we had a central supply or a generating station. You know, we know that the changes in South Africa towards renewables becomes now more distributed generation. So the instrument and the system allows you to monitor and measure, you know, distributed throughout your system, what is the impact of a particular renewable energy generator on your entire system. So I think it's important to realize that the energy discussion is becoming more and more important in South Africa.
Good. I see something about the certification and so on. The devices are fully certified by NMI, which is one of the real reputable third-party certification organizations within the Netherlands. And we certified our device at 110 volt, 1 amp. And I think that's also something that's important, because many of the other devices certified at 230 volt and at full scale current. But we are sitting in a world where we have 1 amp and 5 amp there, and it needs to be within compliance levels at those points. So, I must also, I think, add something. I don't know whether you are aware of a technology that's called low power VT and low power CTs. LPVT, LPCTs. This is a very exciting technology that it's literally a resistive or a capacitive voltage divider that you install when you don't have VTs or CTs available. It gives out a small signal, typically in the order of 4 volts from that. The big advantage of low power VTs is twofold. It's dirt cheap. And if I say dirt cheap, it's dirt cheap. And the second thing is that it is broadband. So as a power quality consumer or generator of data, moving into industry, seeing so many measurement points where we don't have VTs installed, this provides an incredible opportunity for us to do that. So we modified our device and we can now directly interface to these low power VTs and CTs as well. Just a comment there as well. You can install a low power VT in the cable area when a cable comes from the trenches into your switching cabinet. Now on that C-type bushings, depending if there's enough space and so on, but at the back of the boot, you can screw in a VT. It's as simple as that. I must say also the biggest challenge with low power VTs and CTs is that sometimes the boots just don't support, most of the time the boots just don't support the use of a low power VT. And that means you got to replace that termination with a new terminal and a boot, and that can be troublesome. But at least there's a solution for it.
Really, just to confirm, is that up to 33 kV cables, or is it only for low voltage cables?
Up to 33. I've seen 66 as well. And I've seen outdoor posts as well. We use this now in the railway space because the entire railway space has never been monitored. And so we measure the 3-phase rectifier stage with red, white, and blue, the first 3 channel. And the 4th channel we use to look at the traction DC voltage and current. And to measure voltage there, we use a normal post insulator, low power post insulator. And I'm going to do a little bit of marketing for ABB. They've got an incredible range of low power VTs available. Any more questions from your side?
Hello, Willie. Richard here. Can you hear me?
Yes, thank you.
Oh, Willie, a slightly different question. We see there's more interest in harmonics above the 50th harmonic. And I was wondering if you have any insights on how you see that developing in the future and how well placed your meters are to deal with higher order harmonics above the 50th.
Yes. I am going to answer this in two stages because the normal IEC requirement for harmonics up to the 50th hertz, or the 50th harmonic, is troublesome for industry already. We are not even talking about the higher harmonics. We recently did a study, and up to 10 kilohertz, a traditional VT, and I'm not even talking about the CTs, they do perform better, but the VT might have up to at least 3 resonant points before 10 kilohertz. And the first resonant point is as close as 2 kilohertz. So when you traditionally look at the VT's response, there's no DC, there's a flat band elect pass phase, and then it drops off on that side. But what people don't realize is that's the beginning of the resonant point. After that drop off, it immediately jumps up, and it's very, very sensitive. So between 2 and 3, 4 kilohertz, you can make up to 300% errors on a classic VT on its own. So you can see why I'm leaned and driven towards the low power VTs, because these things have got a 10, 20, 30, 50 megahertz bandwidth. So it is nothing like your conventional magnetic wound transformer on that side. Now, the second part of your question, so that is, we are limited right now to the physical environment that we are living in at this stage. The Vector 3 device samples at 500 kilohertz, and we have an analog bandwidth of 50 kilohertz. And we support harmonic measurement up to 25 kilohertz in it. And we also do the higher harmonics frequency bands, those where you don't lock onto the fundamental, but you calculate and combine certain frequency bands together on it, all according to the 61004-7 standard, if I'm correct. And on top of it, we also implemented on the Vector 3 the filters, the individual filters that you have when you want to measure harmonic emissions. According to the standard, you do require a 3-second time constant filter per each harmonic, per each finger that you have of the harmonics. And that is just to completely eliminate any of your mathematical and locking kind of errors in it. So yes, let me leave it there. I think we're one of the only few instruments in the world that has implemented that requirement according to the IEC standard. And we also do harmonic, prevailing harmonic phase angles, or phasers, my apologies. The prevailing harmonic phasers is becoming more and more important in the international market when we are having complaints where a load or a customer actually sinks an harmonic and do the system a favor. And now he sinks the harmonic too high, or the harmonic current becomes too high, and he gets penalized for doing something good to the system. And so that's where the whole concept of prevailing phasers came in. It's the brainchild of Jan Meyer from Dresden University. There's a lot of things that you can read up from that. So he's the champion behind that. Okay. Somebody asked about the frequency performance of the low power VTs. I've mentioned it before. It's in the megahertz range. So it's unlike normal wound transformers. All right. Any other questions?
Billy, I see there's a question about interharmonics in the chat box.
Of course, interharmonics is supported by default. And as I mentioned as well, from the harmonic side, I think we are the harmonic analyzer par excellence. We pulled all the stops, sorry, in terms of harmonic analysis. We can, let me leave it there. I think a lot of effort went into harmonic analysis. On the visualization side, I think we animate when you have a high THD at a certain point of time. Our animations or animation side of the software can give you the harmonic spectrum at that particular point in time. So for instance, if you have a load curve and the load is high, at any point on that curve, you can have the cursor on top of that, and you can see all 64 harmonics, all 64 interharmonics at that time. And so on. It's very valuable the way we animate and visualize the data there. All right. I must say something about the South African industry in general. After all the years being involved in this industry, I must say personally, I'm very disappointed in the level of sophistication and adoption that we've seen throughout South Africa. It will do us very good. I will be very excited if through this presentation, we can start getting questions about the harmonics, about the smaller nitty-gritty things that's happening on the network, and not just basically keeping the lights on. You know, it's if I can tell a quick story here, and I think the Stellenbosch gentleman will forgive me there, but we measured the power quality and energy at every single one of the 11 kV output transformer. They've got a 66 kV ring, and when we combined the energy together, the active energy was within 0.1, 0.2% from the same energy that we measure on the Eskom supply points. However, the reactive energy was constantly out with 15 megavars. And we found that the capacitance, or that the capacitive energy stored in Stellenbosch cables is constant of 15 megavars, lying buried in the ground. Interesting things that came out there. All right. I think at this point in time, I'm going to stop the presentation. I will still be online, so if any person will want to ask me still more questions and so on, you are most welcome. And please feel free to contact us directly. And if I can say a final note, I hope that you will see CTLab with different eyes. In the past, we've been associated just with power quality. And for many years now, we have built this whole Otello platform, and we've built a lot of capability in it, and people just don't know about us. So please, we are South African based. We are fully in charge, and we own all the technology that we have. So we can modify, and we can grow, and we can make new things, and we will be very excited to have partners that can walk this road with us for the future. So thank you very much for everybody attending, and I'm still available for questions.
Really, just another question from my side. In terms of continuous grid code compliance and monitoring, have you guys looked into adding the ability of including apportioned limits within the Otello software to basically manage your apportioned limits and not just on the NRS limits?
Yeah, Francois, yes, grid compliance is the new hot topic for everybody out there. We have a challenge though that through the years, power quality was defined. So power quality being a group of things to look at: regulation, unbalanced DHD, flicker, and all these kind of things. But the whole grid compliance phenomena is not properly described yet. So one of the things that you talk about right now, the emissions and those kind of things, I think it's an area of concern and of importance to many people. And we are just waiting for, if you, for instance, have a need for it and you can give us some information on exactly how you want it to be done, I'll gladly listen to you. The synchrophasers and the onboard processing capability of the Vector 3 just lend itself now to gain access to the high-speed stream of data, to access it and analyze it on board to do this kind of thing. So yes, Francois, it's on the cards right now, and but unfortunately, with all the COVID-19 headaches that everybody's got, there's very limited budget for investment from our own side to do this kind of thing.
Yeah, no, sure, I understand. Yeah.
Hello, Billy. It's Dave Duncan. I'm just wondering about the measurement of the directional flow of harmonics, which when we were trying to get some of the wind farms running, it became extremely difficult to say that they knew exactly which way it was flowing. In other words, were you causing additional harmonics or reducing them exactly as you said, as absorbing them? And the only method seemed to be, has the harmonic voltage contact increased with the wind farm generating? If you switch the wind farm off, does it decrease or increase to try and imply who is the importer and who's the generator?
Yeah, I think an important one with harmonics is you have two worlds combining here. You've got background harmonics, and then you've got harmonics being generated. So your wind plant or your renewable plant responds to the background harmonic by syncing or obviously just syncing it, the harmonics, or on the other hand, it's generating it. And it is a difficult task on how to do it. What is just of importance here is that the Otello system maintains all the phase angle information that you require to make that decision. With other words, right now there's not software available or a system available that can tell you what has happened, but at least I have a very complete data set that you can use with more consistent outcome, with a more consistent outcome on that side. So the prevailing phasers, the phase angles, and all those kind of things that's available. And the fact that it's time synchronized, with other words, you can now have two measurement points at different locations, maybe put an impedance in between. And by comparing the data, you can literally have calculate the direction of the harmonic current by looking at the voltage on the one side and on both sides and comparing the phase angle and the current through it on that side.
Thank you.
Okay. If you leave me talking, I will still continue with many questions and so on. I see there are still quite a few people online.
There's a question from Jan de Kok. When will the Vector 3 be able to report up to 5 kilohertz harmonics?
it's already doing that 5 kilohertz. It's well, I mean, we do up to 25 kilohertz. So 5 kilohertz is already there. Something that I forgot to tell you is that the Vector 3 also have the ability to compensate for harmonic non-linearities. So you can have a non-linear sensor, and we can compensate obviously within. So we use a fourth order polynomial to compensate for amplitude, and a third polynomial for phasing as well. And the same goes for the voltage side and so on. And just to answer Jan's question correctly here, we support the harmonics up to the 64th harmonic, which is roughly 5 kilohertz on it. And we also support up to the 25th harmonic on, 25 kilohertz harmonics in the frequency bands that you have there. But it's highly dependent on your sensor that you use.
Hi, Billy, it's Ronald speaking. This is maybe slightly outside of the quality of supply area, but I'm interested in under transient conditions, when there's faults on the network, how is the performance of measurements during those conditions?
All right, the IEC standard has defined a few standard things for us. So dips and swells is the most commonly known one. The second one is the concept of a rapid voltage and a rapid current change. And the rapid voltage and current change, it's literally saying that if you move from a steady state at one level to a steady state at another level, and there was, for instance, a 1 or a 2 or a 3% change, then we can trigger onto that. So it will, you can literally trigger every single tap change operation from a tap changer, or you can see whether the load rapidly changed. Just a comment on that, that rapid voltage and current change is quite a powerful tool when you want to calculate network impedances, because you have a set of data with the voltage current on one level, and you've got a set of data with a voltage current on another level at almost the same time. So if you have a lot of them, you can calculate network impedances, but I must say it is not an easy task. There are students or people in the field that this is not an easy task. But it's a powerful tool to start using that.
Okay, because during those conditions, the system doesn't have a steady frequency. The frequency varies at multiple places, and determining how the frequency moves across the system would be of interest. Yes. So I'd like to understand kind of what resolution or how long does it take to measure those frequencies on an accurate basis under those transient conditions?
All right.
And can it be done? Yeah.
Yes, yes. I'm going to answer also in two different ways. The first one is that the device itself, unlike what the standard calls for, is sampling at a fixed rate. So your waveform capturing and things is at a fixed rate of 50 kilohertz. So your waveform data is never diluted with a phase locking algorithm that changes the sampling rate as you go through. So the recorded data with pre and post, if you're not happy with the kind of information that we derive from it, you can do so yourself, and you have good quality data because it's a fixed sampling rate. And also what is nice about that fixed sampling rate is that there are also all the devices samples are time stamped to within 2 microseconds from each other. In other words, the samples doesn't have decimals because the GPS locks them to be on within plus minus 100 nanoseconds from 2 microseconds. on that side. So it's quite powerful. It simplifies the analysis of data and so on that side. From the device itself, we have every zero cross that sits there. We have the instantaneous frequency, but this doesn't exist. You know, when you look at zero crosses, we are looking at an ether, and the frequency there is more phase shift related than frequency related. But at least that information is available. So you can take that raw data and filter it. The frequency is stuck within that. So that's another way of looking at it. And keep in mind, it comes from the synchrophase data as well. So our device can start recording a frequency profile at once every cycle for you to bring that down. But during diagnostic information, I have all that information every half a cycle, actually every sixth of a cycle. We do on every zero cross of every phase, we calculate everything. So red has got 2, white has got 2, blue has got 2. So in one cycle, we have 6 sets of phases that you can use to calculate your frequency. From that, we have a 10, 12 cycle frequency block. From that, you have the 3-second blocks or the 10, 12 block, the 15 block data from it and higher up. So all those frequency streams are available.
Great, thank you very much.
Okay. And just also comment, all of those parameters, you can access that on some of your protocols. So you can make it part of your business processes.
Really, David Duncan again, just a query on CTs and their frequency response and the possible use of Rogowski coils with their inherent phase shift, giving you a bit more analysis to do.
Yeah. Right now, we use billing class, billing certified Rogowski coils in our case, and with a built-in integrator. And we can compensate for any one of the harmonic anomalies. With that is, we take the Rogowski coil, put it on a test bench, generate a curve from that side and compensate for that curve. And we found that the Rogowski coils are quite good in terms of their phase performance. The interesting thing with most of the split cores and including the Rogowski coils is that their fundamental energy phase shift is sometimes larger than expected. Simply because the integrators struggle with the lower frequency and they're just doing much better with the higher frequency on the one side. And on the split core CTs, the little small split core CTs, is the cores are just too small to have the 50 hertz fundamental. So some of the split cores produce significant phase shift at 50 hertz already.
Okay, thank you.
The session was recorded, it is still recording. And if I'm correct, we're going to make this recording available soon on the web. I believe, also if I'm correct, keep in mind, my apologies, this is our first webinar. And we are most probably going to email you some notification on where to find the recording of this session, if you were still interested in sharing some of it then outside, yeah. Rui, do you have any comment there from Brazil? It's good to see you.
Hi, Willy. Not much comment so far. Sorry. I'm moving to the oil and gas industry And then, you know, I'm not aware of the news from this area, but I wanted to participate and see what you guys are, you know, developing and everything.
All right. Thank you.
Nice to see you.
Maybe I can ask one thing here on, do you believe that the systems can be then effectively used in microgrid controllers, not just as a data collection, but where the high speed data communication bidirectional can be used?
SEP, we have all the DNA to do that. We have been talking to a renewable system integrator that is looking at, I forgot now what that word would be, where you sell to your neighbor electricity. So a trading, point-to-point trading within the system, and also on the control side. In their case, they already have some control functionality of their own, and but all the DNA is available within our technology to do exactly that. With other words, we can have device-to-device communication. You can have device-to-central point communication. You can have some crypto technology to make transactions between engaging partners on that side. So the sky is the limit there. This will be a very exciting application. And may I say another one is that CT Lab is already drawing up specifications for what we call an edge monitoring device. So right now our device is sitting on top and moving down into the grid, but there is a tremendous need, as we've seen today with some of the questions as well, for an edge recording device. And that edge recording device must have some control functions to be able to curtail the renewable sources. And we don't know yet how deep we're going to get. I'm very fond of the idea to have, to gain access to the Internet of Things market, where we can control devices behind the billing meter and so on, but using the Internet of Things technology. It's the most flexible and open technology on that side. But yes, please talk to me. Just on the platform itself, the platform right now in its full-blown state runs on server technology. But I think when you talk about the microgrids and so on, we will most probably be able to run an application for the whole system on one of our devices. I think, gentlemen, shall we call it a day at this point? I hope we stimulated interesting thoughts, and please contact us if you also have some interesting thoughts and idea that we can participate with. Okay, so at this point, I'm going to greet you and thank you for participating and spending the hour and a half with me today. Thank you very much.
Thanks, Willie.
Thank you.
Possibly I'll try and contact you.
Willie,
Yes, Rui.
Yeah, I think, you know, I could mention 2 points that was one of the subjects we talked in the last time. One of those you have nicely addressed, which is the direction of harmonics. It was one of the topic that was quite hot in Brazil. Several buddies trying to investigate and find out in the wind and solar farms, if they were causing harmonicas or absorbing harmonicas or something in the middle, they were causing something or being caused by the local harmonic content. So I think you addressed it quite well. So it's you have a very accurate data set, and then one could do measurements and assessment by that. And the second one was concerning, the common ground in Brazil. People use to apply those perturbation graphs, something like that, and they have, more precise capture, sampling data set and everything. Do you have any news about that? The Otello and the readers, they can measure in such a way in comparison with those equipments. Did I make myself clear?
Yes,
question?
I think, Ray, if I understand correctly, you are asking me whether we can interface to a specific device, I think a perturbograph or something like that.
Yeah, perturbographs, yeah.
Yeah. I've heard the name of the device, and there were not a specific requirement or inquiry to directly interface to them put to us yet. So if you think that's worth a while and so on, then I think the first step, if we will most probably have to contact the technology supplier directly to ask whether they would be interested in us supporting them on our system.
Okay, that's a great idea.
Yeah.
I'll come to you shortly, okay? I'll come to you later on to talk about that.
All right. Thanks, Ray. Hallo Kobus. Het is goed om te zien. Dankie.
Dankie.
Gentlemen, I'm going to pull the plug on my side, and I'm in serious need of a cup of coffee. Thank you very much for everybody.
Thank you, Vali.
Okay, bye-bye.